Hey there, space enthusiasts. Before we dive into one of the most thrilling cosmic mysteries of 2025, I want to know, where are you watching from today? Are you tuning in from a bustling city where light pollution hides most of the stars? Maybe you're somewhere rural where the Milky Way stretches across your night sky like a cosmic river. Or perhaps you're on the other side of the world, watching this while I'm fast asleep. Drop a comment and let me know your location. I love connecting with fellow space lovers from around the globe. There's something magical about knowing we're all looking up at the same universe, isn't there? Now, imagine this. You're an astronomer scanning the night sky, doing what you've done thousands of times before. It's the 1st of July, 2025. Just a regular night at the Atlas telescope in Chile. But then, you spot something that makes your heart skip a beat. A tiny point of light moving far too fast, in completely the wrong direction. Within hours, you realize you've just discovered something that traveled here from another star system, carrying secrets from the depths of interstellar space. That object is 3I, Atlas. And friends, it's turning out to be even more mysterious than the famous Oumuamua. In the past few weeks, NASA's most powerful space telescopes have been studying this visitor, and what they've found is absolutely mind-blowing. Let me paint you a picture of that historic night. The Atlas survey, that's the Asteroid Terrestrial Impact Last Alert System, consists of 4 robotic telescopes spread across Chile, South Africa, and Hawaii. Every single night, these mechanical sentinels take around 800 images each, scanning our cosmic neighborhood for anything that might pose a threat to Earth. On the 1st of July, 2025, the Atlas telescope in Rio Hurtado, Chile, was performing its usual sky survey when it captured something extraordinary in the direction of the Sagittarius constellation. What made this discovery particularly special is that Atlas telescopes have a unique advantage. They can photograph the bright galactic plane where most other surveys fear to tread due to overexposure issues. The object was initially designated A11Ple3Z, but as more data poured in from observatories around the world, astronomers realized they had something unprecedented on their hands. Pre-discovery observations dating back to the 14th of June were found in archives from the Zwicky Transient Facility in California and other Atlas telescopes. Here's where it gets really exciting. When astronomers crunched all this data, they discovered the object had a hyperbolic orbit with an eccentricity of around 6. Now, for those of you keeping track at home, anything with an eccentricity above 1 means the object isn't gravitationally bound to our Sunday. With an eccentricity of 6, this comet has one of the most extreme hyperbolic orbits yet measured, marking it as a definitive interstellar visitor. This earned our mysterious guest the official designation 3I Atlas, the 3rd interstellar object ever confirmed to pass through our solar system. Now here's where 3I ATLS starts to get really interesting. This comet is traveling at a breakneck speed of 58 kilometers per second. That's about 130,000 miles per hour. To put that in perspective, if you could somehow catch a ride on 3I Atlas, you could travel from New York to Los Angeles in just about a minute. This makes 3I Atlas the fastest traveling interstellar comet we've ever observed, significantly faster than Oumuamua's 26 km per second, or Borisov's 32 km per second. But speed isn't the only thing that sets this cosmic visitor apart. Let's talk size. Remember Oumuamua? It was roughly the size of a football field. Impressive. A 3-eye Atlas absolutely dwarfs it. With an estimated diameter of 10 kilometers, this makes it an order of magnitude larger than Oumuamua and even bigger than Borisov, which measured between 1–2 kilometers in diameter. Think about that for a moment. We're talking about something roughly the size of Manhattan Island, hurtling through space at unimaginable speeds, carrying with it the chemical signature of another star system. Now, here's where our story takes a dramatic turn. Just a few days ago, NASA made an announcement that has the entire astronomical community buzzing. NASA's James Webb Space Telescope has made its first observations of interstellar comet 3I Atlas, revealing that the comet appears to be unusually rich in carbon dioxide. On the 6th of August, 2025, the most powerful space telescope humanity has ever built turned its golden mirror toward our interstellar visitor. What it found was absolutely unprecedented. The comet has the highest ratio of carbon dioxide to water ever observed in a comet, which implies that the comet contains ices that were exposed to much higher levels of cosmic radiation during its journey through space. Let me break this down for you. When James Webb analyzed the spectrum of light from 3I Atlas, it found signatures of carbon dioxide, water, water ice, carbon monoxide, and even carbon sulfide. But here's the kicker. The amount of carbon dioxide relative to water is unlike anything we've seen before in any comet, whether from our solar system or beyond. The abundance of carbon dioxide in the coma of 3I Atlas could indicate that the interstellar comet has a heart that is intrinsically rich in carbon dioxide. This tells us something profound about where this object came from and the conditions it experienced during its journey through the galaxy. Now here's where 3I ATLS starts to get really interesting. This comet is traveling at a breakneck speed of 58 kilometers per second. That's about 130,000 miles per hour. To put that in perspective, if you could somehow catch a ride on 3I Atlas, you could travel from New York to Los Angeles in just about a minute. This makes 3I Atlas the fastest traveling interstellar comet we've ever observed, significantly faster than Oumuamua's 26 km per second or Borisov's 32 km per second. But speed isn't the only thing that sets this cosmic visitor apart. Let's talk size. Remember Oumuamua? It was roughly the size of a football field. Impressive. A 3I Atlas absolutely dwarfs it. With an estimated diameter of 10 kilometers, this makes it an order of magnitude larger than Oumuamua and even bigger than Borisov, which measured between 1–2 kilometers in diameter. Think about that for a moment. We're talking about something roughly the size of Manhattan Island, hurtling through space at unimaginable speeds, carrying with it the chemical signature of another star system. Now, here's where our story takes a dramatic turn. Just a few days ago, NASA made an announcement that has the entire astronomical community buzzing. NASA's James Webb Space Telescope has made its first observations of interstellar comet 3I Atlas, revealing that the comet appears to be unusually rich in carbon dioxide. On the 6th of August, 2025, the most powerful space telescope humanity has ever built turned its golden mirror toward our interstellar visitor. What it found was absolutely unprecedented. The comet has the highest ratio of carbon dioxide to water ever observed in a comet, which implies that the comet contains ices that were exposed to much higher levels of cosmic radiation during its journey through space. Let me break this down for you. When James Webb analyzed the spectrum of light from 3I Atlas, it found signatures of carbon dioxide, water, water ice, carbon monoxide, and even carbon sulfide. But here's the kicker. The amount of carbon dioxide relative to water is unlike anything we've seen before in any comet, whether from our solar system or beyond. The abundance of carbon dioxide in the coma of 3I Atlas could indicate that the interstellar comet has a heart that is intrinsically rich in carbon dioxide. This tells us something profound about where this object came from and the conditions it experienced during its journey through the galaxy. Let's take a step back and compare our 3 interstellar visitors. First came Oumuamua in 2017. That cigar-shaped or pancake-shaped mystery that sparked wild theories about alien spacecraft. It showed no cometary activity, had unusual acceleration, and left us with more questions than answers. Then came 2I Borisov in 2019, which behaved much more like a typical comet, with a beautiful tail and predictable activity. It was reassuring in its normalcy after the enigma of Oumuamua. Now we have 3I Atlas, which seems to combine elements of both predecessors while adding its own unique characteristics. Like Borisov, it shows clear cometary activity, but it's less active than Borisov was at similar distances from the Sunday. Yet its chemical composition is unlike anything we've seen before. Each of these visitors tells us something different about the galaxy beyond our solar system. Oumuamua suggested there might be very different types of objects out there. Borisov showed us that some interstellar comets are remarkably similar to our own, and 3I Atlas is revealing that interstellar space might contain objects with chemical compositions we never expected. I want to take a moment to appreciate the incredible technology that made this discovery possible. The Atlas system is a perfect example of how modern astronomy works. It's not just one telescope, but a coordinated network of robotic observers that work together 24/7. Each Atlas telescope takes around 800 images every night, and the system has registered 1,212 near-Earth objects that will pass within 1.3 AU of our planet. The fact that these telescopes can scan the bright galactic plane where other surveys struggle due to overexposure was crucial for this discovery. Then there's the James Webb Space Telescope, humanity's most powerful space observatory. JWST observed 3I Atlas on the 6th of August, 2025, using its near-spec integral field unit, which provides spatially resolved imaging spectroscopy over a 3 arcsecond by 3 arcsecond area with 0.1 arcsecond resolution. This level of precision allows us to not just detect the presence of different molecules, but to map exactly where they are in the comet's coma. It's like having a molecular microscope that works across interplanetary distances. One of the most important scientific questions that 3I Atlas helps us answer is, how many interstellar objects are actually out there? Scientists have estimated a density of just 0.001 interstellar objects per cubic astronomical unit of space, PLA, far smaller than previous estimates made when we discovered Oumuamua and Borisov. This might seem like a small number, But think about the vastness of space. Even with this low density, the number of interstellar objects passing through our solar system at any given time is staggering. We're just now developing the technology and techniques to spot them. The discovery of 3I, Atlas, also validates the importance of continuous sky surveys. This density estimate is based on the fact that Atlas has been scanning our skies for the past 3 years and has only found one interstellar object so far. But the density is liable to change and depends on many other factors. Every interstellar visitor teaches us something new about the galaxy we live in. These objects are like cosmic time capsules, preserving conditions from their formation billions of years ago and carrying chemical signatures from distant star systems. The high carbon dioxide content of 3I, Atlas, suggests it might have formed in a stellar system very different from our own. Perhaps it came from around a cooler, older star, where carbon dioxide could more easily condense into ice. Or maybe it formed in the outer regions of a system where temperatures were low enough for these volatile compounds to survive. The age estimates for 3I, Atlas, are particularly mind-blowing. If it really is 3 to 11 billion years old, this object predates our solar system and has been wandering the galaxy since the universe was much younger. It's traveled potentially hundreds of thousands of light years, surviving the harsh radiation environment of interstellar space while preserving its original chemical composition. Now, here's some exciting news for all of you amateur astronomers out there. You can actually observe 3I, Atlas, using ground-based telescopes starting around September, and it will be visible until it disappears behind the Sunday. After its the 30th of October perihelion, the comet will re-emerge from behind the Sun in early December for another round of viewing. While you won't see it with the naked eye, a decent amateur telescope should be able to pick it up as it brightens approaching the Sunday. The JPL Horizons website has a handy tool to track its position in space, so you can plan your observations accordingly. Imagine, you'll be looking at an object that has traveled farther than any human-made probe, carrying with it the chemical fingerprint of another star system. That fuzzy dot in your eyepiece contains molecules that formed around a different sun, possibly billions of years ago. The astronomical community's response to 3I, Atlas, has been nothing short of electric. Michelle Bannister, an astronomer at the University of Canterbury in New Zealand, explained that working on the 2 previous visits from interstellar objects were transformational opportunities, science-wise, and this visitor will likely encourage the same level of excitement. Amateur astronomers and experts alike are contributing their own observations through platforms like the Astronomer Telegram, which is being updated daily with new revelations. This collaborative approach is one of the beautiful aspects of modern astronomy. Discoveries like this unite professional and amateur observers around the world in a common quest for understanding. The rapid response to coordinate observations shows just how precious these opportunities are. Interstellar objects don't wait around for us to study them. It is already, they're here and gone in the cosmic blink of an eye. I'd be remiss if I didn't address the elephant in the room, the suggestion by some researchers that these interstellar objects might be artificial in origin. Dr. Avi Loeb, the former chair of Harvard's astronomy department, has been vocal about this possibility, both for Oumuamua and now for 3I Atlas. While it's important to keep an open mind in science, the evidence strongly supports a natural origin for 3I Atlas. The presence of water, carbon dioxide, carbon monoxide, and other volatiles detected by James Webb, is exactly what we'd expect from a natural comet. The cometary activity, the spectral signatures, and the behavior all point to this being a fascinating but fundamentally natural object. That said, the unusual chemical composition does raise interesting questions about planetary formation in other star systems. Perhaps what we're seeing isn't evidence of alien technology, but rather evidence of how different planetary systems can create very different types of objects. The discovery of 3I Atlas marks a turning point in our ability to study interstellar visitors. We're no longer caught off guard by these objects. We have the infrastructure and expertise to rapidly mobilize our most powerful telescopes for detailed studies. Looking ahead, survey telescopes like the Vera Rubin Observatory will revolutionize our ability to detect interstellar objects. When it comes online, it will survey the entire visible sky every few nights, potentially discovering dozens of interstellar visitors every year. This rapid cadence will allow us to build up a statistical sample of interstellar objects, helping us understand not just individual visitors, but the broader population of objects wandering between the stars. We'll be able to answer questions about the typical size distribution, composition, and orbital characteristics of these cosmic wanderers. As exciting as our current knowledge of 3I Atlas is, we're still in the early stages of studying this object. The comet won't reach its closest approach to the Sun until late October, and that's when things will get really interesting. As 3I Atlas gets closer to the Sun, its activity level should increase dramatically. More ice will sublime, creating a larger and brighter coma and potentially a more prominent tail. This increased activity will give us even more opportunities to study its composition and behavior. The high carbon dioxide content detected by James Webb raises so many questions. Is this CO2 coming from the surface layers, or does it represent the bulk composition of the object? How does the CO2 to water ratio change as the comet gets closer to the Sun? These are the kinds of questions that will keep astronomers busy for months to come. The study of interstellar objects like 3I Atlas is about more than just understanding individual visitors. It's about understanding our place in the galactic community. Every star system ejects material as it evolves, sending up objects that become the wanderers we occasionally detect. Our solar system does the same thing. Right now, there are probably objects that originated around our Sun making their way through interstellar space, potentially carrying Earth's water or Mars's atmosphere to distant star systems. In a very real sense, we're all connected through this cosmic exchange of material. The chemical signatures we detect in these objects tell us about the diversity of planetary formation processes throughout the galaxy. Some systems apparently create objects rich in carbon dioxide, others in water ice, and still others produce mysterious objects, like Oumuamua, that don't fit any category we understand. I want to take a moment to appreciate just how far our technology has come. When Oumuamua passed through our solar system in 2017, we discovered it almost too late to study properly. By the time we realized what we had, it was already on its way out of the solar system. With 3I Atlas, we've done so much better. We detected it months before its closest approach to the Sun, giving us time to coordinate observations with our most powerful instruments. The James Webb Space Telescope, which wasn't even operational during Oumuamua's visit, has provided us with unprecedented chemical analysis. This technological advancement means that future interstellar visitors will be studied in even greater detail. We're building up both the hardware and the expertise to make the most of these rare opportunities. Behind every astronomical discovery is a human story, and 3I, Atlas, is no exception. Think about that astronomer in Chile on the 1st of July, scanning through hundreds of images looking for potentially hazardous asteroids. In the space of a few pixels on a digital image, they discovered an object that had traveled farther than anything humans have ever sent into space. Within hours, this discovery set in motion a global collaboration involving telescopes on multiple continents, some of the most advanced space telescopes ever built, and hundreds of astronomers working around the clock to extract every possible bit of information before this cosmic visitor disappears back into the darkness between stars. This is what makes science beautiful. The moment of discovery, the excitement of the unknown, and the global collaboration to understand something that expands our knowledge of the universe. As we continue to study 3I, Atlas, over the coming months, we're also looking ahead to future discoveries. The European Space Agency's Comet Interceptor mission, scheduled to launch in 2029, will station itself at a gravitational balance point in space, waiting for the next interstellar visitor. When that next visitor arrives, and it will arrive, Comet Interceptor will be ready to intercept it with a formation of spacecraft that can study it from multiple angles simultaneously. This will give us our first close-up look at an interstellar object, potentially revolutionizing our understanding of these cosmic wanderers. There's also ongoing discussion about missions to catch up with Oumuamua, despite its head start. While challenging, such a mission would finally answer the questions that have puzzled us since 2017. As we wrap up our deep dive into 3I, Atlas, I want to step back and consider what this discovery means on a cosmic scale. We live in a universe where matter is constantly in motion, where objects formed around distant suns billions of years ago can end up in our cosmic neighborhood, carrying with them the chemical fingerprints of alien worlds. 3I, Atlas, represents a physical connection to the broader galaxy. Its high carbon dioxide content tells us that, somewhere out there, conditions were right for this molecule to condense into ice. Its ancient age connects us to the early history of our galaxy, when star formation was more active and the cosmic environment was very different. In studying objects like 3I, Atlas, we're not just learning about comets or asteroids. We're learning about the galaxy we call home and our place within it. We're discovering that we're part of a vast, interconnected system where material flows between star systems over cosmic timescales. So, where are we now with 3I, Atlas? We're witnessing one of the most exciting astronomical discoveries of 2025. An object that's already rewriting our understanding of interstellar visitors and the chemical diversity of objects beyond our solar system. The James Webb Space Telescope observations have revealed chemical compositions unlike anything we've seen before. The high carbon dioxide to water ratio is a puzzle that will keep planetary scientists busy for years to come. As the comet approaches its closest point to the Sun in late October, we'll have even more opportunities to study this remarkable visitor. But perhaps most importantly, 3I, Atlas, represents our growing capability to study the galaxy beyond our solar system. Every interstellar object we detect and study brings us closer to understanding the broader cosmic environment we inhabit. To everyone who's been following this journey with me, keep looking up. Whether you're observing from a light-polluted city or under dark rural skies, remember that we're all part of this cosmic story. 3I. Atlas has traveled billions of kilometers and potentially billions of years to visit our solar system. And through our telescopes and space missions, we're able to reach back and touch that distant origin. The universe is vast and full of mysteries, but discoveries like 3I, Atlas, remind us that we're developing the tools and knowledge to explore that vastness and uncover those mysteries. We truly live in a golden age of astronomy, and the best discoveries may still be ahead of us. So what do you think? Are you excited to potentially observe 3I Atlas yourself in the coming months? What questions about this interstellar visitor would you most like to see answered? Drop your thoughts in the comments below. And don't forget to let me know where you're watching from. I love connecting with fellow space enthusiasts around the world. Until next time, keep exploring, keep questioning, and keep looking up at the cosmic wonders that surround us. The universe is out there waiting to be discovered, one interstellar visitor at a time.